For decades, science and literature have treated human cognition as a strict binary. On one side, we have the sleeping brain, generating the chaotic, fragmented imagery of dreams. On the other side, we have the waking brain, enforcing the structured, logical rules of conscious thought. We experience sleep as a high-entropy state of unpredictable turbulence governed by emotion. Waking reasoning, by contrast, operates as a rigid, highly ordered network of constraints. Because these experiences feel so different, we assume they are biologically isolated modes of thinking. But mapping the brain's physical dynamics tells a different story. The Brain Kinematics Model, or BKM, is a framework that measures cognitive states based entirely on the flow of physical strain and energy through neural networks. Under the BKM framework, dreams, logical reasoning, and the narratives we call fiction are not separate biological systems. They are simply different stability regimes existing within a single, continuous topology of mind. We can construct this cognitive phase space geometrically. By defining the axes of neural activity, we can pinpoint the exact physical coordinates where scientific reasoning, REM sleep, and literary fiction manifest. Recognizing this continuum shifts our understanding of consciousness. It shows us exactly how the brain scales its physical parameters to generate meaning across every state of awareness. To build this phase space, we must first isolate the physical variables defining a cognitive state. The first parameter is amplitude. Amplitude measures the strength of neural activity and local strain intensity. This is the physical load of emotion, typically driven by the amygdala. High amplitude means a memory or concept is exerting a massive gravitational pull on your attention. The second parameter is frequency variability, or FV. This dictates transition speed. High variability means rapidly switching between completely different memory attractors. Low variability means moving smoothly along a predictable path. The final parameter is coherence, the degree of logical control exerted by the prefrontal cortex. High coherence forces brain signals to hold together, ensuring one thought leads to the next in a structured causal sequence. With these three axes, amplitude, frequency variability, and coherence, any mental state can be plotted as a precise physical coordinate within this geometry of neural strain. We test this geometry by mapping the absolute extremes of human cognition. REM sleep's profile is defined by maximum emotional amplitude, maximum frequency variability, and minimal coherence. During REM sleep, the prefrontal cortex biologically downregulates. With logical constraint realised, raw emotional energy drives rapid, chaotic jumps across disparate memory attractors. The exact opposite coordinate is focused analytical thought. High coherence suppresses emotional amplitude and locks the network into highly synchronized pathways, where one premise strictly follows another. These two extremes dictate our exact experience of reality. We either endure a chaotic emotional storm with no logical consistency, or process a rigid, predictable sequence stripped of emotional weight. Because these extremes represent pure entropy or pure rigidity, neither state is highly optimal for generating rich, narrative human meaning. The cognitive state we call fiction sits in the exact center of this phase space. It is a highly specific regime that balances amplitude, variability, and coherence. Fiction operates on a unique principle called segmented coherence. It builds logic in distinct, isolated blocks. In this middle state, the prefrontal cortex exerts just enough constraint to maintain local logic within a single scene. This creates high segment strength, ensuring the immediate action makes sense. At the exact same time, the brain allows enough frequency variability between those scenes to create transition softness. Instead of strict causal logic, the mind accepts soft jumps in time. We measure this with the Narrative Coherence Index, or NCI, a formula calculating how local attractors form and connect. By optimizing the NCI, the brain balances the free, associative exploration of the hippocampus with the causal rule sets required for waking life. Reading or writing fiction is the utilization of an optimized neurological state. It is a cognitive tool designed to safely explore emotional extremes without breaking the stability of the mind. This diagram maps how cognitive representation changes across the phase space. We replace our physical axes with linguistic outputs. sign density on the x-axis and symbol density on the y-axis. Focused thought is sign-dominant. It relies on precise, one-to-one definitions with minimal ambiguity. Dreams are symbol-dominant. They rely on compressed imagery, where one object represents 5 different emotional concepts. Fiction is a hybrid. Linguistic signs provide the structural pathways, while symbols provide the emotional depth and energy landscape the signs travel through. When we plot specific literary genres on this map, we find they are not arbitrary artistic labels. They are precise coordinates. Realism sits in the high coherence, low symbol zone, maintaining strong causality. Increasing symbolic intensity shifts the coordinate up to magical realism. Dropping prefrontal coherence entirely pushes the system into surrealism, a coordinate functioning almost identically to REM sleep. We see this in practice. Woody Allen's The Kugelmass episode uses high emotional amplitude and surreal logic to act as a pure REM-like wish fulfillment dream. Alice Walker's Everyday Use relies on strict logic and moderate amplitude, operating as a highly structured NREM-like section to process memory and identity. Literary genres are exact descriptions of different neurodynamical configurations in the human brain. Because dreams and fiction share the same thematic space, they often inspire each other, but translating between the two reveals a strict thermodynamical asymmetry. Translating a dream into a functional piece of fiction requires an active expansion and stabilization. The brain must select specific emotional attractors from the dream and build logical, sequential pathways between them. The reverse process, having a dream that is based on a piece of fiction, is a non-reversible, lossy compression. During sleep, the logical structure of the story violently collapses. Multiple distinct narrative elements, characters, and timelines shatter, compressing back into singular, volatile, symbolic nodes. Because lossy systems are not reversible, you can never perfectly reconstruct the logic of a story from the dream it inspired. The structural data is gone. To process the world, human cognition requires both extremes: the raw, dense associative power of the dream state and the rigid structural integrity of waking consciousness. But ultimate narrative meaning is found in neither pure logic nor raw emotion. It exists in the exact middle of the phase space, when the chaotic energy of our symbols is guided, but not suppressed, by the architecture of coherent thought.